In this episode, I'm going to show you how to reverse proxy your WebSocket connections directly to Asterisk while hosting your HTML and JavaScript files in Apache web server. We're going to do this all on the same Raspberry Pi box. So that means we're going to be making our own certificates. So if you want to find out how to do that, stick around. Hey guys, thanks once again for joining me. My name is Conrad de Vet, and this is Innovate Asterisk. So in a previous video, I showed you how you can host both the JavaScript and HTML files and your WebSocket connections inside Asterisk. Now this is nice if you want to just play around, but I've been getting people ask me what to do if they want to take this to production. And is this viable? Now, it's not really viable, I must say. Asterisk really isn't designed to be a web hosting service. And if you're opening Asterisk to the public, it's probably not a good idea. So what you want to do is you want to have Apache be the web server while you have your WebSocket connections connect directly to Asterisk. The reason why we want to do this is to keep Asterisk separate from the web service, separate from the public-facing environment. Now, we can't get away from our WebSockets being able to connect to Asterisk. We have to have that, but they can be proxied in from Apache. So Apache will end the HTTPS connection and reverse the connection back through to Asterisk on a different port. The other reason we might want to do this is that Asterisk might not be running as root. In fact, in a lot of installations, it's not. And you cannot run an HTTPS service on port 443 if you are not running as root. So Apache can be doing that, and your web hosting service can still be using port 443 and reverse proxy the connection into Asterisk, which is no longer using port 443. In fact, they cannot. They would clash with each other. So they have to be running on different ports. The other thing that you can do in Apache is that you can really fine-hone the SSL connection and achieve an A+ rating. Now, in this example, we're going to be making our own certificates. So we will need to take our CA certificate, that's our signing certificate, and install that on our computer, which we generate from Apache box. But that's fine. I'll show you how to do that, and then you will have a secure connection. If you wanted to extend this project any further and host it on the web, and you could prove that you were in control of the domain, then you could use Let's Encrypt certificates. But for the moment, and for this demonstration, we're going to make our own certificates so that you can see how the process works. So in order to do this, I'm going to first start by flashing the SD card that my Raspberry Pi is going to run with. Now, in previous videos, people have asked me if this was really necessary to describe these steps each time. Well, over the last while, the system has changed. So every time there is a change to the system, I will do it in the videos. But yes, if you know or are familiar how this process works, you can skip to the next section. But I'm going to now flash the SD card using the Raspberry Pi imager so that we can run our Raspberry Pi OS. If you haven't already, you need to go to a website called raspberrypi.org. And over here, you go to software and our software and download this imager, all right, for Windows, Ubuntu, or for Mac. I'm on a Mac. I've downloaded and installed this application. Once it's downloaded, you can then use this application. I will click choose, and I will choose not this default one, which is the desktop one. I will use Raspberry Pi OS Other, and I will use the light version. And then under choose storage, I need to insert my SD card. I've now inserted my SD card, and you can see it pops up over here. I select it, and now I click write. Yes. It will prompt me for my password. Right, now the card has been written, and in fact on my Mac it has ejected it. So I do need to do one more thing before I continue. I'm going to eject and insert my SD card again into my computer. When I do that, it comes up as boot on my device list. So I'm here, I'm going to go sudo nano, and it'll be volumes, it'll be boot, and I want to write SSH password, and then Control O for out, and X to exit. So I have my SSH file here, and what that will do is will by default give me access to SSH, because when I plug this in and onto my network, I will not have a monitor or anything like that. So it must be available on SSH. Right, so I take my SD card out of my computer and I put it in the back of my Raspberry Pi, and I give it a network connection like that, and I give it power. When you give it power and a network cable, it'll go through the boot process and be available on the network on a special URL. That URL is raspberrypi.local. I'm going to go and find this device on the network. So I can say ping raspberrypi.local, and it should respond to me unless it hasn't propagated on the network yet. So there you go. Right, so now it's responding to my ping requests, which means I can access it via SSH. In order to do that, I type in SSH and then type pi, which is the username, at raspberrypi.local. That's the same address that I used over there. Now, if you get this message, which is what I usually get, because I've done this before, it means I need to edit this file. So over here, I need to take that file and edit it. So I'm going to go sudo nano, and this file wants a password, and you'll see that I still have Raspberry Pi over here. Take it out with Control K, Control O for output, and Control X to exit. Now I can go back to SSH Pi Raspberry Pi local, and now I need to add it again. So yes, and now it's asking me for my Raspberry Pi password, which is Raspberry. Okay, I'm now in my Raspberry Pi. So people have been asking me before, is there another way that I can publish the commands that I type rather than having to read them off the screen? They're picking up a lot of typo errors. What I've done with each one of these episodes is I've made a GitHub page, project page, so that you can copy and paste them. This is GitHub, Innovate Asterisk, Season 2, that's this season that we're on, and this is Episode 1. So it'll all be the same, Season 2, Episode 2, etc., etc. You'll be able to find it, and I'll publish this in the comments. And over here, you can see the steps we've taken so far and the rest of the steps that we're going to take. So I will be using these very same commands in order to complete this task in front of you in the video. But if you want to do the same thing, you can copy and paste the commands out of this, and that way you don't get any typos. So the first thing we're going to do on our Raspberry Pi is become root. So I'm going to go switch user, and I need to do that with sudo switch user. All right, and now I'm in as root, and I'm going to do a couple of things which I normally do in the beginning of any installation, and I'm going to go apt get update. Right, packages are now all up to date, and there's a couple of things which I need to install, which I sort of do by default each time. So again, if you are familiar with this process, you can skip it, but essentially we're going to install these files now. Right, those applications are installed. One of the applications that I've installed is called Samba. It's an old file sharing program that allows you to see the files and folders on the Raspberry Pi, much like you would any computer on a network. But in order to do that, we need to configure a couple of things. So I'm now going to add the Pi account to the system. So I need to type in the password, the same as the root password, Raspberry, and then again. Okay, it's added Pi to Samba. Okay, now we can edit the Samba config. So I'm going to go here, and I'm going to go down to the bottom, and I'm going to just drop that whole block in, which is basically that. Innovate Asterisk is now going to be a share. Its path is on the root, and all the various settings are set for me to be able to do what I need to do. So Control O for output, enter, Control X to exit. And now I need to restart the SAM service, and the command for that is service smbd restart, and then I can exit from root. Okay, so now I'm back to my user and I have access to this on the network. So to do that, I go to Finder. In Windows, you'll just go to Network Neighborhood. Then I go to Connect to Server, and I choose Raspberry Pi.local, and I choose Connect. It now asks me for my username and password, which remember is Pi and password Raspberry. And it gives me the share which I've just created, Innovate Asterisk, right? You remember that we just made that. So that's the share I want to access. Once that's loaded, I have now full access to my Raspberry Pi. Right, we've installed our Raspberry Pi, and we have got a few tools which we've installed as well. And now we're going to go on to installing Asterisk, and in this case, I'm going to install Asterisk version 18. So whenever you're watching this video, it doesn't really matter what version, because all the principles are going to be probably the same. In order to download so that I can start installing Asterisk, I'm going to use wget, that's my command, and I'm going to wget the latest Asterisk 18. I'm going to be doing some WebSocket calls. So the truth is that I really want to use Opus Codec. Now, Opus Codec does work with browser phones and Asterisk. Digium don't produce the Opus Codec in downloadable format through the Make Menu Select. It's in an x86 format, and that's not useful to us on our Raspberry Pi. In order to install Opus Codec on our Raspberry Pi, we need to clone another project and include it in our setup process. It takes a little bit longer, but in the end, we'll have Opus Codec for our Asterisk installation. So over here, I'm going to git clone the following project. All right, I'm going to untar my folder. Then I'm going to go into it. I want Asterisk 18 there. I now want to become a root user again. So I want to sudo su. So I'll be at the same place, but just as root, because what I need to do now is I need to install all the prerequisites. Contrib scripts, install prerequisites. Okay, excellent. We've installed all the files that we need. Your installation may have taken a little longer than mine. And now we need to continue to a few extra things. So this is the Opus files that Asterisk will not use directly, but the Opus Codec will use. So that's now installed. That's a dependency. And we now need to include a few extra items for the Opus to be included in the build. So this includes the source files into the build. It's just these three things. Again, you can copy and paste it from the GitHub page. And then I need to run configure for Asterisk, configure with PJ project bundled included in my command line. Great. There you go. That's what you want to see. Again, yours might have taken a little bit longer than mine, but there you go. If you see this, then you're in a good position to go and do the next option, which is make menu select. Now, in menu select, I like to change a few things and just double check that a few things are enabled. So I'm just going to take you through that now. Right, so at the start here, all the applications are on, and that's fine. The bridging modules are on. The call detail records, I'm going to switch off, but you don't need to. This is only because I don't need to be call detail logging right now, and I don't need to be channel event logging. So I'm going to switch all of those off. My channel drivers is fine, so that's there. And I've got my codec and my codec translators, and you can see codec open source over there. That's the inclusion of the new things that we did in that update. Format interpreters are there, and that's fine. My dial plan functions are fine. PBX modules, everything is no problem with that. My resource modules I'm going to leave as is. Test is all off, but anyway. Now I do like to do better back traces over there, and if in fact it does actually crash, which I don't think will be the case, and I don't need any of these because this is a fresh install. Okay, so I don't need my AGI samples, and I don't like to use GSM. I will use WAV for my sound packages. There's WAV, that's fine, and no extra sound packages. So that's all I'm really going to do. I want to do save and exit, and that exits my menu select. Now, the next is a combination command. I want to do the following. I want to use make install, and make config. So I'm going to run them back to back, and then you'll see the asterisk install after that. All right, and eventually you get to this. Sure, that might have taken you a bit of time. Thank goodness for video. Right, so at this point, Asterisk is installed, but it won't actually work. There is no .conf files in the Asterisk folder. So although this is installed and it is correct and it has Opus codec, it's not actually going to run right now. Now I'll get to installing the conf files from the GitHub project location, but for the moment I need to install the certificates, or generate the certificates that we're going to use, and we're going to generate our own. In fact, we're going to generate a CA certificate. That's a certificate authority that we're going to use to create other certificates, but we also take that CA certificate and we install it on our computer so that our computer knows the authority of the certificates that our server is presenting, and it can trust the certificate connection. So at this point, I'm going to now exit from my root. I can do the following things as a normal user. So I'm just going to go to my root directory, and then I'm going to make the following folders. So make directory, CA, certs, and certificate signing requests. Then I'm going to use OpenSSL to create my first CA root certificate. Okay, and I need to give it a password. So give it a password that you can remember again. For the moment, I'm going to give it a simple one because I'm going to type it a few times. Okay, I'm now going to create the actual certificate where I use my password protected key file, and this is going to output the Raspberry Pi root CA. Okay, so if I use my key, which is password protected, I need to type in that password. Right, there you go. Now it's going to ask me some questions, and I'm going to answer them with basic information, something that you can type in as you like. I'm just going to type some sort of none data. Let's put here innovate asterisk, and over here might as well just put innovate.com. You will see where these come out, and for the name I want to call this the Raspberry Pi root CA. Right, and I'm going to give it my address, conradjdw@gmail.com. Right, here you go. So I've now created my root CA certificate. Now I'm going to create a signing request for my server certificates. Now these are the certificates that are going to present when the server is hosting a HTTPS service. So here you can see it's outputting my key file. And again, it's going to ask me to type in some information. So give it a country code, give it some state. Yep, some state will be fine, wherever. Some city, it doesn't really matter this information. We're going to use it privately. Private company, my private company, whatever you may be, and it is located in the headquarters. However, this is important. At this point, I should give it my correct local address that I'm going to use, that raspberrypi.local. So this must be raspberrypi.local. So that must be the address that we type in order to access our site, which we already know because we pinged right in the beginning that raspberrypi.local resolves to that IP address. Okay, now this is really for version 1 certificates, 1 or 2 I think it is, but we're going to, for consistency and backward compatibility, use this address in here, raspberrypi.local. And for my address, email address, I'm just going to leave it blank, but also leave it blank for all of these other 2 sections over there. Okay, so now I have created my signing request, and I now need to create my certificate. So remember, if I was an authority, an actual authority, I would have been, I already have my server key and my signing authority certificates, and you as a user would have gone through this process over here and created a signing request and essentially handed it to me in order for me to sign. But because we're both the authority and the user, we're going to do both parts of it now. So I need to create a little text file first. This is my OpenSSL version 3 CNF file, and inside there I'm just going to copy and paste it exactly as it was from essentially the GitHub page. And here DNS.1, so one of the DNS names that this responds to, this is valid for, is raspberrypi.local, which is the same as what you've just entered under your common name field. I'm going to go Control O for output, press enter, Control X to close. Now I can generate my certificate. So this is my server certificate. This is the file that my server will present whenever it hosts my service. So I'm going to choose this command, OpenSSL. There's all the parameters. You don't have to really understand them. You can copy and paste them straight from the GitHub page. But one of the options here is that file that we've just entered, OpenSSL version 3. Otherwise, it's just the output, the key file, and the CA root certificate, the CA key. Now remember, in order to use my CA key file, it will probably be prompting me for the password. So let's see. That's right, wants the password. This is the same password that I generated, that I gave it right in the beginning. So there you go. I enter my password and it generates the file. Now I know, for example, something that is quite useful is to have a PEM file. Now a PEM file is actually just a certificate which combines the two. So my cert and key just combined into a PEM. All right, it's the same thing. Raspberry Pi cert, Raspberry Pi key. I think you will find that we generated this one out here. So that's the one that we made. And then the key was what we created over there. So I make a PEM file. And the one thing I know is, in order to use my PEM file, certainly my key file, I do need to give it the correct permissions on the file. So I'm chmodding that, and I now have all the correct things I need. Let me just show you. So ls-l, give me my CA cert. One other thing I can do just to show you is that I'm still connected to my Innovate Asterisk share pile on Samba. So I can do things like this. It's kind of useful, right? So there is my CA stuff. That's my CA certificate, CA key, and then these are this would have been a file that OpenSSH created during this process. It's the serial number for the certificate, and this is the cert file, the key file, the PEM file. Remember the PEM file, which is a combination of these two. And then I don't really need this again, but there's my CNF file and my certificate request file. So that's not really useful anymore again, but these files over here are useful, and this is useful here as well. Now what I do need to do is I do need to actually take this file and bring it onto my desktop. And I'm going to do that in a second, and I'm going to show you how to install it so that we can validate these certificates. We already used this CA certificate to sign these certificates. So on the receiving side, on the desktop device side, I need to install the certificate so that I can once again do that. So I have Asterisk installed. It's not really running at the moment. The configuration files need to be there still. I have my certificates. I haven't installed my root CA certificate yet. I'm going to get there too. The other thing we can do is install Apache and tell it where the certificates are as well. Remembering that Asterisk is not going to host the WebSocket connection under HTTPS. It is going to do it under HTTP, because otherwise it would conflict with the Apache service, which will be running under HTTPS. Right, at this point, I'm going to now go back to my terminal, and I'm going to clone the project that we are busy working on. So this is git clone Innovate Asterisk season 2 episode 1. Now that I have cloned my GitHub project, all I really need to do is copy, that's this command cp, the project season 2 episode 1 config, all the files to etc asterisk. So if I do that now and I go back to here, you will see that under Innovate Asterisk etc asterisk, I have all the config files that I now need. Now you can review these files on your own in your own time, but some of the things have been set up. So pjsip.conf has got some data in it. So I can actually just show you right now. So you will see it's got some templates in it over here, which I'm going to use. So I am actually going to use these configurations. Now, what that means is if you have got an existing project and you want to modify it, just start with these configuration files for now, and then apply your modifications later once you understand how it all fits together. Now, the next thing I'm going to do is I'm going to configure one of the config files in this project. So I'm going to go back to my folder and I need to configure http.conf. Now, http.conf is currently enabled no, and TLS enabled no as well. But I want it to be as follows. Right, I want it enabled yes, and I want it listening on this, what looks like a peculiar IP address. But this is essentially the same thing as saying localhost. But why it's not 0000 is that I don't want it exposed to the network at all. Now, 127.0.0.1 is an IP address that's only accessible to this very computer. In other words, it refers to itself. So that's my bind address. It is the HTTP binding, and you will see here TLS enabled is still no. We are not going to be accessing this device, or at least Asterisk, under HTTPS. We're only going to be accessing it via the HTTP service. Right, I'm going to save that. So you can see I've saved it now. And now I'm going to go and install Apache. To install Apache, I'm going to make myself root again. Sudo su. Okay, I'm in the same place, but as root user. I need to install a couple of things. So I'm going to install these options over here, this Apache 2. So it asks me to install it, and with all its dependencies. Apache is installed, but there's a few things I need to enable. And I enable them by doing this A2 nmod. So Apache 2 enable mod. I enable SSL. I'm going to enable proxy. I'm going to enable proxy HTTP. And I'm going to enable a very special service, which is to enable proxy WS tunnel. See that? That is really what allows me to have connections reverse proxy back into Asterisk from Apache. Now let's go and make some changes to Apache's configuration so that we get Apache working. Right, under ports, I've got here if module, all this kind of stuff, and look, we're able to actually just clear all of that out. So I'm just going to take all of that and replace it with just one thing. So you'll see it's doing all sorts of things, if module and all that kind of stuff. Now I know that it is there and loaded because I added it. So I'm just going to simplify that to listen on all IP addresses on port 80, 443, and 4431. Now that's interesting. 4431, what's that? Well, here's what you need to understand. Although my WebSocket connection for my HTML and JavaScript is going to host off 443, that's this one here, my WebSocket connections cannot really be on the very same port. So I do need to distinguish differently WebSocket connections of a different port. So I'm going to make up, you can see I've just added one. I'm going to make up a port number for myself. Listen on 4431 and establish this as a separate, essentially a separate hosting entry point, and forward those connections on through into my WebSocket connection into Asterisk, right? So normal HTML files will host off this, WebSocket connections will host off that. Now, generally speaking, WebSocket connections, you just simply type in the address, colon, and the port number. And it's generally something that customers are not expected to do. You wouldn't expect them to type in 4431 into their web browser. That would be confusing. So you simply type in, say, google.com, and it redirects you. You wouldn't expect them to type in colon 443 or 4431 for that matter. But WebSocket connections are only really consumed by devices which are in code or behind the scenes. And that's why we have control over that, and we can type that port number in separately. Now, if you are in such a way that you don't even want to type in HTTP, HTTPS, you can actually use this as a redirect. So if somebody happens to get to the site through raspberrypi.local without typing HTTPS in there, this can redirect them to this, which is then HTTPS raspberrypi.local, and then our WebSocket connection will use that. But that's something in JavaScript, and that's something we have hard code for. So in order to set up these sites, I'm going to go to, I need to exit that with Control O for output, Control X. I need to go to the following address. All right, nano, etc, Apache 2, sites enabled, that's important, sites enabled, and then inside there is something called 00-default conf, right? This is what Apache give you as a default configuration. And again, it's not important what they've got here. I don't really need any of this stuff, so I'm going to take it all out. Just going to use something a bit quicker. Control K. Moves all the lines. All right, so what I'm going to do, and I'm going to take you through each section. I'm going to copy and paste the values from GitHub, but essentially, remember where we said 0000:80, that's a redirect. Well, there's our command, redirect anything to HTTPS raspberrypi.local. Okay, HTTPS is important here. So that HTTPS is actually redirecting us to here. And then this is essentially a completely separate WebSocket connection. All right, this is a completely separate address, which has been told to do the proxy pass reverse proxy. And that's with these two lines over here. So first of all, we're hosting a regular HTTP file, right? A default file, and we're giving it a server name, a location, an error log. We're switching SSL on, and there you will see home Pi search, Raspberry Pi search. Remember that certificate file that we created, the key, that's that one, and our SSL settings. Now you will find that with a lot of these settings enabled, the certificate will actually qualify for an A+ rating, or at least an A anyway. And so we have no risk in exposing this to the public internet. And then over here, which is another port, and it's not the same port as that, another port, also listening on all IP addresses, so it doesn't really matter for what binding this is. Different server name, essentially the same server name, also a log, same folder. Now, the reason this might be confusing for you, so what would happen here is that if somebody actually did type in :4431, they would be served the same default page as that, right? But we're not going to expect people to type that in. We're going to only really host something on /WS. And this is where we want this the service to redirect us. And it's kind of like saying, well, if you do land up on this page sort of by mistake, just show a default page, but when you type in /WS, it's going to perform the reverse proxy, and this is interesting. So it performs the reverse proxy after being on SSL engine on to WS, which is without SSL. So the SSL certificate actually expires here and a new connection is established without a secure link back to 127.0.0.1 port 8080. So let me show you where that came in. Let me just move this to the side. So here, go here, HTTP, open that up. So can you see that now? That there, proxy pass /WS, is essentially going to this address, 127.0.1, bind port 8080, /8080, /WS. Now this /WS is actually something that is generated by Asterisk. So you don't see it here, and I will show you that /WS in a second. But just know that this is the binding address, local machine binding IP address, bind port 8080, and here's our reverse proxy. So this sends this connection into Apache, into Asterisk over here. I don't have TLS enabled. You see, it's not enabled. It is an HTTP listener, and this is where I end my SSL connection over here. The SSL connection actually terminates here. It doesn't go any further, and the connections are now under regular TCP, which is actually using the WS protocol, back to this /WS folder here. So in order to get any further now, I need to restart my Apache service. So I'm going to choose Service Apache to restart. I also need to restart Asterisk. So I'm going to choose Service Asterisk Restart. At this point, Asterisk will be accessible and working to some degree. So I'm going to first exit from my root. I'm now as a normal user, and in order to access Asterisk CLI, I still need to use sudo. So sudo asterisk -r. Now asterisk -r is quite an important command to get to the CLI. I'm now in Asterisk CLI, and there are a couple of things I wanted to show you. So first of all, I can show you, if I press tab, I get all my possible commands, and I want to type HTTP. I can choose show status, and here the one thing you'll notice is that /WS. One thing I find quite useful to do is to run netstat with the commands -tu/nlp, and this gives us a sort of a snapshot of the open ports on the server and what we are listening under. Now, if I run this as sudo, so sudo and then netstat, I will get also the names. So there you go. 127.0.0.1, and that's opened port 8080, and you can see here, no foreign addresses, no connections yet, but there it's running as Asterisk. At the same time, I've got Apache running on port 80, and I've got Apache also running on 4431, and then Apache running on 443. Okay, so these are all my services. Asterisk is exposed itself. It's not able to reach it over the network, but I'm able to reach it through Apache on port 8080, and then these are all my front-facing services, Apache. All right, I've opened a web browser page here, and I've typed in raspberrypi.local without the S. You see here? I could even just take that part away, but I want to force Chrome to first go to the HTTP page, and let's see what happens. Right, this is expected actually. So what's happened is that it's redirected us to the HTTPS page. It's quite important that you see this. So it's saying that the certificate is invalid. right? Because remember the Apache service was set to redirect HTTP traffic to HTTPS traffic. So there you go. So it did the redirect, which means that our Apache is working. It also means that our HTTP is working, except for this certificate issue. Now, what's happening here is we created a service, a CA certificate, a signing certificate. It's a certificate authority, but our computer, that's this computer, does not understand that certificate authority. So what we need to do is we need to install that certificate onto this computer. So I'm going to go back now and I'm going to find my Raspberry Pi, and under Innovate Asterisk, under Home, that was Home Pi, I'm going to take it and pop that onto this file here. I'm going to pop it onto my desktop like this. I'm just going to drop it on here. Replace. I already have one, obviously. So under a Mac, you get this option to just simply double click it. So I'm going to simply double click this file, and you will, after typing in your password, you will see that the certificate chain manager opens up, and inside here it has got this Raspberry Pi root CA file. Now, under Windows you'll need to actually import it, but for Mac users you just double click it and you get to keychain access. And if I double click the certificate, it's got all the details that we know about. So we know the common name of the CA certificate was root CA. We typed in this organization unit as the web address. We did all these things, remember from earlier on. The one thing that it doesn't have is the trust. So under trust over here, I'm going to use always trust. And that changes this file to be a trusted certificate. Now, when you close this window, it's going to ask for the password again. So I type it in now, and it's got this little blue plus on it here. This certificate is marked as trusted for all users. And this was the root CA certificate that I had generated on the Raspberry Pi and brought into this computer. So whenever I go back to it again, you will see that I can actually see that that certificate is a trusted certificate. Over there it is with a little blue plus. Okay, and where that makes a difference is now Chrome knows to trust it. And there it is. Great, so we have the default Apache Debian loading page. We have it running off a certificate that we generated, and we have got all the information we need here. You can see that there's the CA certificate, the signing certificate, and all the details. Now we've told it that this is marked as trusted, but this certificate is what came off the server. So it offered this certificate through Apache. Remember things like my private company, HQ, all that information. So this is the issuer information, which was part of that. You can see the key chain of trust there. All right. So there is a web hosting service using our own certificate, and Raspberry Pi.local is our domain. We would obviously need that in order to use certificates. And now we can host some basic pages and use a WebSocket connection to establish a connection back to Asterisk and test that our WebSocket connection is working. At this point, you can test this configuration with any WebSocket phone that you like. However, I've got another little project that I work on from time to time, a little browser phone project. So I'm going to show you how to use that project to create a browser phone environment and log into Asterisk using WebSockets. If you go to the following website, Innovate Asterisk Browser Phone, that's github.com, Innovate Asterisk Browser Phone, you'll be able to clone or download this project over here. So you can copy this URL over here. So let me do that. I've copied it. I'm now going to go back to my Raspberry Pi, and I'm going to clone it. So git clone my project. Once I've cloned my browser phone project, I'm then going to go to that folder, browser phone, and it's the phone folder that we want. Okay, so I'm going to say sudo cp phone star, everything under phone, to var www html. It's omitted, so I need to say cp -r recursively, and now cd var www html, sorry, and there. I have all the files and folders that I need running on my Apache web server, and I would have overwritten anything that was there. So if I just go back to my browser and press refresh, now what's important in this application is that we connect to our Asterisk server as Raspberry Pi.local, and remember our WebSocket port was 4431, remember that, and is WS. So to put some users in, I'm going to go back to Visual Studio, and I'm going to open up some files from the file explorer here. I want to go to Innovate Asterisk, etc. Asterisk, and under pjsip.conf, I want to go to the bottom of this, and under users, drop in some users. Now these users are already set up in the GitHub project, so you just use them, save, and let's go back and change the dial plan. So dial plan is extensions.conf, so that's this, and I've got a very basic dial plan which takes everything and hangs it up. So let's put something a bit more useful in. I've got something to override this whole lot, so there. Subscriptions for subscribing, I've got from extensions for these extensions to dial. They will dial each other except for if they don't match, they will play music on hold. Right? Very simple. So save that. But now that I've made changes to my dial plan and my extensions, I need to go and restart Asterisk. So let me go back to here and say sudo service asterisk restart. Restart. All right, so I've restarted Asterisk. Let's go to Asterisk so that we can see what's happening. Sudo asterisk -r, and here I can see Asterisk and whatever's happening, and over here I can open up the web browser, and here I can type in the users that I created. So I created 100, which is my extension. This guy is called 100, shame, poor name. My SIP username, user1, so that's your, let me show you where that comes from. And pjsip user1, so that is my username, user1, 123. It's all that same thing. So password 1234. For the moment I'm using SIP as a chat engine, that's fine. Under audio I have got some settings over here, microphone volumes, and even a webcam. So I can show you how to make a video call. Under appearance, I've got some things like pictures and stuff like that I can choose to put up. I'll just put username in there and save that. Now when I make changes to that, it wants to reload. It's then also going to offer the terms and conditions. I accept those, and there it's registered. Okay, so there's my first user registered on that system. Let's see what happened on the CLI. You can see here added contact and essentially one user registered. Okay, what happens here, to show you a bit more in depth about how this all works, I'm going to right click somewhere in our desktop and choose inspect. Move that over a bit so you get more space. But essentially what's happening is interesting is here under network. Now it won't be recording because I've opened the developer tools after the page loads. So I'm just going to hit reload again, and then I'm going to show you, see what happens here. So what happens now is you get, scroll down to the bottom, you see here, you get this WS connection, okay? Remember that is a /WS, and you can see on the tooltip, WSS, remember it's WSS is the secure connection, WSS Raspberry Pi.local :4431. So remember that is what we typed in under the Apache default site settings, and this is with an HTTPS connection. So some interesting things under the headers, and you will see that it's got the upgrade, and it's 101 switching protocols, which is correct for WebSocket connection. And also there, very interestingly, we've got messages. So inside this WebSocket connection, this sort of, let's call it a TCP tunnel, is our actual SIP messages, including the normal stuff like register, responses, auths, and everything that happens over here. So it's including a subscribe and all that basic information. So this subscribe will probably be a voicemail subscribe. Yeah, voice messages, all right? And basically it is going to be sending and receiving SIP messages from here. Okay, so there is a basic telephone, and if I add somebody like a test, and I say that the test is address book contact, and it is *65, add that, and I call it I get music on hold. Can't really hear that so well, but the CLI should show you playing music on hold. All right, so there it is. We created a Raspberry Pi installation. We installed Raspberry Pi OS. We then installed Asterisk and Apache, and got Apache to be in the front line, so to speak, with a secure connection and a certificate. We installed that certificate onto our desktop computer so that we could access the port on the secure connection. The WebSocket connection went in a different port and under a different //WS. That directed immediately through to Asterisk. And that's the important thing about this, is that Asterisk is not the front line in your server. Apache will be doing all the hard work, heavy lifting, and SSL connections. And Asterisk is only left to deal with the voice and video calls. Right, so that's the video. If you enjoyed it, give it a thumbs up. And of course, don't forget to subscribe if you think that this channel is going to give you some value. That's it. Thanks for now. Bye.